this basically reviewed everything we've done so far, basically. Word problems, just simple solving, right? Using sine law, cosine law, whatever pertains. So make sure you make the corrections that go with it. If you're watching this video, I have handouts for you, so come and get it from me when you're back. Given the following triangles, determine the value of the indicated side or angle. So we're asked to find this. At first glance, it doesn't look like you can do anything, but you have two angles, you really know three, right? So angle F would be 180 minus 41 minus 62. So angle F is 77. So this would be worth 1 mark. So now I know that this is 77. I have a pair. I know this is sine law, right? Sine of 77 over 1375. And then it's sine of 62 over E. E is equal to 1375 times sine of 62 divided by sine of 77. And that gives you 12.46 miles. Okay, if all else, at least write down the answer and try this later on. Perfect. I'm just going to check here. It's the large, not the largest angle. It's the median in the middle, right? But it's definitely should be smaller than the side across 77. So that checks out. We're good to go. Next, we've got side, 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 right? That's a classic giveaway. You have to use cosine law. In this case, they're asking us to find this, which looks obtuse, right? So cosine of x, right? The first number you write down is the one across from it. That has to be subtracted like that. And then it's 11.4 squared plus 7.9 squared. Make sure you have these formulas. And this formula is when you're having three sides, then this is the only one that you can really use, right? 2 times 11.4 times 7.9. Notice that this side does not show up again, right? It's only showing up there once. That's the one across the angle. You get negative 79.88 over 180.12. Okay, so I would give you, at this point, you would get 1 mark, right? If you show me the setup and then these numbers, angle X is cosine inverse of that, which is negative 0.443, and that keeps going. Or just type it in exactly like that as a fraction, that's fine. And that is 116.33, which is what we expected. We expected an obtuse angle. The diagram told me so. The negative here gave me the hint, right? So there you have it. That's how you would solve that one. Okay. All right, moving on. So that should be, I'm expecting you to know how to solve, right? And if you're stuck, go back and try, right? We did quite a few of those. Compass directions for the following. So I see that it's starting north, right? So you go north 65 degrees east. That should be that one. Here, I notice that the angle is touching west, right? So it's west 18 degrees south. Okay, this one is touching south, so south 21 degrees east. Okay. And then draw the following. I'm going to grab my ruler. Well, you don't really need a ruler for this one. North 25 west. North, and then you turn 25 degrees west. Right, so this is the 25 supposed to go in there. And then this one is west 55 south. So you start towards west, you turn 55 south. It should be past 45, right? So that's what you put there. And then this one is starting south, and you're turning 71 west. So this is to be a bit more realistic. It should be closer to the west line, right? So there you have your, and I could ask you, hey, how else can you describe this? You should know that this is west. Like you just flip the letters and you find the complement, not the supplement, the complement, right? Whatever gets you to 90, so that'll be 19 degrees, right? So that's something that I would expect you to be able to do real, like quite on the spot, right? Just make that happen, right? And if you're not sure, draw your direction, right? 71, you're like, oh, there's 19 here. So this is west, 19 south, right? Like it's either way, you should be able to do that. Next page. Scuba divers. This one was I was very specific here, so there was no like how do you draw this again, right? Because I'm telling you, there's diver one, diver two. They're um, 25 meters apart on the surface of the water. Right, so 25 meters goes there. I'm gonna go. Um, they spot the shark below them. The shark is to the right of diver one, so this must be diver one, and to the left of diver two, right? So it's somewhere in between. Um, sorry. Yeah, they're below the surface of the water. They spot a shark below them. The angle of depression from each diver is 47, so this would be right 47 here because there is a horizontal, and then from diver 2 that is 39. Okay, so that would get you a mark right there if it looks like that. Calculate the distance from each diver to the shark. So again, let's call this S for shark, right? I will do that. I'll calculate angle S right here. I know two of the angles. Do that right away. If you know two, you really know three, right? That's how it goes. If it's isosceles, if you know one, you actually know them all if it's an isosceles triangle. And this gets you, let me see here, 94. I get 94 degrees for this one here. Okay? And there I have my pair, so that's that's sine law, right? I will make this on my diagram. I'll make reference to this side as x and this side as y. If you do that and then solve for x and y, you get the marks because you show me exactly on the diagram what it is that you're solving for. So sine of 94 over 25 meters is equal to sine of, if you do 39, right, you're solving for side x. And then I will do another pair. I'll use the exact same pair. In this case, if I use 47, right? If I use angle 47, I'm solving for side y. I'm going to skip this step because I know you know how to write that, but I expect you to do that. 1577. This is 15.77 meters, and this y is 18.33. Right, so you've got your two sides there. Distances from the divers to the shark. And right, double check. 47, right? 47 is the greater between the two, right? So I do expect that to be a longer distance than the other one. I'm going to cut this here. How far below the divers is the shark? So what is it asking? Hand height, right? I'm nice enough to tell you that in this case. So it's that height there that is you're asked to find. And you have two choices because you know both of these and the angle that they touch, right? So I'm going to go with x here, 1577 times sine of 47. Either way will work. That is 11.53 meters below the divers. And if you go, what's the other side there? 18, right? If you were to go 18.33 times sine of 39, you get the exact same answer. It's actually 11.54. Not a big deal. Just show your work, okay? That's all you need to do. So right triangles can appear. You may cut them and work with the right triangles if you'd like. That is always an option. And now let's do some compass directions. This is actually question 5, and this is actually question 6. So just to make that clear. Okay, direction planning and scouting. And leaves the parking lot. So this is my starting point here. Leaves the parking lot at a direction of north, 23 west. So that goes here, obviously, right? The 23 would go there. Walks for 5.6 kilometers. All right, he reaches a swamp and turns in the direction west, right? So this is west, 43 south. So that 43 should go there. Okay, for 2.4 kilometers. Given this information, fill in the diagram and then transfer the final information to this triangle here, right? So I'm actually closing my triangle, and I'm transferring that there. So I know for sure that this is 5.6 and this is 2.4. That is a given. You can take the 23 with you because it's not inside the triangle, but there's something that you can do, which I don't know if you noticed. You can bring this in like that, right? Because this line, the direction, don't make my head hurt on Friday, right? Don't do it. But this line here, this line is parallel to that line. The north-south line, no matter where you go, they're parallel, right? So we get to transfer the 23 in there. So I'm going to use a red pen here to show that I'm transferring the 23 in there. And what about I still need this piece right here, correct? How would I find that? What angle is formed right here in this corner? There's a 90 there, yeah. So to get that piece in there, I'm going to go 90 minus 43, which is 47. Ah. So the compass rose follows you wherever you go. It follows you, right? And so but north and south is parallel wherever you go from the starting point, right? So you can use that to your advantage. So let's do this now. This would be then, right? It turns out that this would be 47 plus 23, okay? Which is exactly 70 degrees. So the 70 goes in there. How can we make the 90? I don't know. I feel like it's too busy if I do more. It's going to do more damage, right, if I add to it, but you should realize that there's a 90 here, okay? And that allowed me to do 70, and this would be SAS, right? So you could solve it using cosine law. Another one here, this one involves solving, okay? A plane leaves the airport and travels 230 kilometers in the direction, so these go together, right? Direction south 30 east. Lands to pick up some passengers, so stops, right? Then flies this distance at that direction to reach the final destination. Sketch and clearly label the angles formed. So let's go ahead. Let's focus here on where are we starting? We're going southeast, right? So imagine, put your pencil anywhere, right? And you imagine if you go south and then turn 30 east, you're going this way at first. So this is probably a good starting point here. Start. And then I'm gonna use the compass partially like this. And I'm gonna turn 30 degrees and go here. Right? Where you land. And so the 30 goes in there. And then it says flies 450 kilometers. So let's make sure the 230 is in there. to 30.4. Then it's north. Watch this. Just follow what you're doing here. North 42 degrees east. So you're going this way and you travel that way. So the 42, make sure the 42 goes between this dashed line and the direction, not the whole thing. Right? Does that make sense that it's not the whole thing? Okay, it's just here. And you're flying for 450 kilometers. Remember what I told you? Don't do this. Some students are like, it would be sweet if it just goes like that, right? I'm just going to stop right there. No. So either cut it short, but I see that it's a longer stretch, right, comparatively. So I'm going to go past it. I'm going to shoot past it like this. Okay. So this is 450.1. You can close it if you want. I'm going to make that a dashed line for now because that was not given to us by the question, right? So that would be your initial story. You see alternate interior, right? This line and this line. So bring the 30 in here. And look at that, the 42 is already there, right? The other portion of that angle. So let's make our clean version here. I'm going to copy that as best as I can, right? So I'm going to call this start. I'm going to call this landing. And I'm going to call this destination. This is what? 72 degrees, right? This is 230.4 and this is 450.1. SAS again. It's not always going to be SAS, guys, but in this case it is. So there's your diagram. Sketch another triangle without the compass rose. I did that. I would strongly suggest you do that, guys. Don't use the messy version, right? This is your story, and now make a clean version of it. Sketch another triangle, and then let's calculate it. So it's asking how far is the airport from the plane's final destination. So we're asking for this. I already did this up there. So it's an SAS, cosine law. And so I'm going to go x squared is equal to 230.4 squared plus 450.1 squared minus. So much work. Cosine of 72. Let's take the root of that. That is actually 191,582.166, and that keeps going. So it's 437.70 kilometers. I look at my diagram, and you don't really have much else to go off of. So you kind of just have to trust your answer there. And so that is how you do one of those. So I hope doing this now, correcting it, makes a bit more sense, right? Allows you to have a better understanding. I want to do one more, guys, in our notes. I know you're like, right, I want one more before I send you off for a long weekend. So get your notes. Get your notes, please, and go to page 17. There's a blank page there. There's a blank page. You're gonna have to write stuff down. You're good, Sadie. It's gonna be on the video, so if you want to look at it again, go for it. But you know, I have about 30,000 views since COVID. Yeah, isn't that crazy? I mean, it's not. It doesn't mean that you're watching every single minute, but I'm still I'm still amazed. So that's why I'm still doing it. Soon I'll be able to make enough to retire. All right, not really. It's all based on subscribers. That's really what it is. So page 17 in your notes. Page 17 in your notes, and I'm gonna make this shorter than the textbook. I just think this one could throw you off a little bit, right? So a police helicopter 400 meters directly above a highway. If you can shorten words, do it, okay? A police helicopter 400 meters directly above a highway, comma, spots an accident, a car accident, a car crash at an angle of depression of, I'm going to go 62 degrees. At the same time, it spots an ambulance at an angle of depression of 27 degrees. I'm going to make an assumption here. Assume the heli is between the ambulance and the crash. Okay, so now I'm not leaving it up for interpretation. I'm kind of assuming, hey, looking up front, right, there's the car crash. Looking back, there's the ambulance coming. So the helicopter is somewhere in between these two. And so we'll go ahead and figure out how far is the ambulance from the crash, so that the helicopter can maybe give an estimated time of arrival, right? And I was gonna ask you to sketch this, but time is running out. So let's try it. Okay, so we've got our helicopter somewhere up here, right? And spotting an ambulance, and at the same time spotting a car crash. So I'm going to call this ambulance and crash, right? And we're obviously assuming that the ambulance and the car crash, right, because it's on the ground, level ground, we're assuming that that's what's going to happen there. We can assume that that line is horizontal. And let's come up with the angles of depression. To the car crash, it's 62 degrees, right? So you need to make up a horizontal line, and from there measure 62. Then you need to make a horizontal going backwards, and you know that to the ambulance it's 27. If you did the homework, you'll recognize this one. But I changed the numbers and it's a bit different. Okay, and what else do we know? We know that the height, right? We're 400 meters directly above the highway. So that actually, I will not make that a side. I will actually just say, hey, this is 400 meters. We could have sketched it outside of the triangle or inside, right? The height stays the same no matter where you go. And in this case, they're asking us to figure out what this is, right? This is really the question mark here. Stretch AC, right? But you notice that perhaps it cannot be done in one shot, right? Sure, I would agree with you. If I find my red pen right there, let's do this. We can bring this in and make this 27, right? We can bring this in and make this 62. Sure, you can do that. Could we now find angle H up here? But would we have a pair? No, because this is the only thing given. I have no other side other than that height. So my approach here, pay close attention to this, I'm going to figure out X and I'm going to figure out Y and then add those up to get me question mark. Okay? Split into right triangles. Okay? Because this is going to happen and you're going to be so used to sine law, right? Like always big triangle, big triangle. I want you to know right triangles still happen. Just right, you just cut it. That's my best sound effect yet. Eh? Okay, so we go like this. I would strongly recommend. I'm going to try to leave you a lot of room when we do a quiz or a test. Okay, so the test may look like it's going to be heavy, right? That's because I want you to have and I probably will I will do the other one right away as well. This 400 stays the same. I know that's a 90. Why do I know it's 90, guys? Because it's the height, right? The height is always measured at a 90 with the ground. And I know this is 62 here. And this would be X and this would be Y. Do you have a pair? You must realize that for both of them you have a pair. Okay? But to find X, what do I need? I need the angle up here, right? For Y, I need the angle up here. That shouldn't be too hard, right? It's because you got the 90. So what's 63? This would be 63. And this would be 8 to get you to 70. So 28. Okay? You just subtract these two from 180 to get you that and that. And so now you can go sine of 27 over 400 is equal to sine of 63 over x. You can't see that, can you? There. And then on this side, sine of 62 over 400, and then sine of 28 over y. Type on time. If you need to just write down the answer, then you do that, okay? And let me just run this because I just got it off the text, right? I don't have the answer to this yet. 785.04 meters. And the y is 212.68 meters. We're not done yet. AC is going to be x plus y, which is going to be 785.04 plus 212.68. AC is 997.72 meters, almost a kilometer, right? If I wanted to, I could say, hey, if you travel 80 kilometers an hour, how long would it take to get there? No time for that. Maybe Monday. Listen, the homework, trig review B. I'll write it down here. Trig review B. Find it in your booklets. Some of you are writing this still. You're writing this down. But if you go through your booklets, there's trig review A, trig review B, and trig review C. I want you to do A and B, right? I already gave you A. B, look for the compass directions. Tests and quizzes. Real quick. It's not coming up just now, right? But next Wednesday, quiz. Next Wednesday, quiz. And then the Tuesday after is test. Okay? Let's still have to do chapter 4. Thank you guys. Have a great day. Great weekend.